The project is bike rental regression project, bike sharing rental. Problem statement is to ensure a stable supply of rental bikes in urban cities by predicting demand for bikes and by considering demand based on various external factors such as weather, season, holiday, etc. Table of contents, data summary, importing the required libraries and datasets, EDA and visualization. Here we have removed the unwanted null values and there's no duplicated values, replaced question mark with the null values and remove null values. And visualization, in the visualization part we have done the point plots, bar plots, and used regression plots and QQ plots. Correlation using heat map. Here highly positive correlation between temp and attempt, casual and register. Count of bikes during weekdays and weekends using point plot, and we observe a peak in the morning hours and in the evening. Count of bikes during weekdays and weekends, unregistered users using point plot. Here high count on weekends. This is registered users using point plot. Count of bikes during different weathers using point plots. Here you can see heavy rain in orange colors where no users booked the bike. Count of bikes during different seasons using point plot. Seasons fall, summer and winter. These three seasons show similar graphs. So period of time, the number of users increases and decreases gradually during different months using bar plot. Count of bikes during different days using bar plot. EDA regression plot of temperature and humidity with respect to the count. With increase in temperature, number of users increases, and with the humidity increases, number of users decreases. Distribution of users using this plot, data is not equally distributed, and here most of the data is in zero quantiles, zero in theoretical quantiles. Distribution of users using this plot, the distribution is more uniform, and the theoretical quantiles, here we can see data is very similar to the red line. Future engineering used one-hot encoding in future engineering data pre-processing. There were no null and duplicated values, and removed the column names and removed columns. They changed object columns to category. Model evaluation. Models we have trained is linear regression, ridge, decision tree regressor, random forest regressor, and gradient boosting regressors. We have used random forest regressor out of 5 models with the least CV score is random forest regressor. So for the deployment we have used random forest regressor. Bike rent deployment, bike rental prediction using light GBM. As we enter features to predict the bike rental count, here we predicted 94. Challenges: data quality. This tends to be missing or unclear data, as evidenced by the question mark and the humidity column of dataset preview. Feature engineering analysis involves multiple features such as date, time, weather, and other factors. Creating meaningful features from this raw data would be challenging. Model selection. Here, analysis compares multiple regression models like new linear regression, ridge, decision tree, gradient boosting, and random forest. Choosing the most appropriate model for this specific problem is challenging. Model performance, handling time series data, dealing with external factors, and handling categorical variable scalability. Thank you for giving this opportunity.